At Dave Cooper Live, we connect the industry leaders in the architectural, engineering, and construction space with the people, the products, and the processes to help them build it better. All right, welcome everyone to Dave Cooper Live, where we connect the industry leaders with the people, the products, and the processes to help build it better. And today we explore how Oak Ridge National Laboratory is developing and deploying technologies that make the building construction industry better. Please welcome group leader Dr. Deanna Hun, sharing her work in building science material and system development automation, robotics, simulation, visualization, and so much more. You may have heard of Oak Ridge or wondered what happened behind closed doors in these research labs. So stay tuned to see how this team is pushing the boundaries of what's possible. But we can't do all of this without our supporting members. So let's thank them first with a supporting word. Forward Solutions Group is successfully driving companies to succeed where others have failed. Are you looking to start a factory, optimize your existing factory, streamline your production, or take your team to the next level? Whatever your needs are, Forward has a solution for you. Reach out to Ben at forwardsolutionsgroup.com. Halleck Ltd. has a long history of innovation in cold form steel manufacturing and producing innovative precision roll forming technology for customers throughout the United States and the world. Check out their machine buyer's guide for off-site modular construction or fast build construction with light steel for framing. Go to their website, halleckltd.com. Brought to you by Greatech, one of the largest Autodesk partners globally and software developer of the PowerPack Advanced Design, Advanced Steel, and the StruxSoft product line. The complete solution to automate wood and light gauge steel framing, design, and documentation all the way out to CNC output, model, design, and manufacture with StruxSoft. Learn more at StruxSoftSolutions.com. All right, again, thank you to all of our supporting members, and thank you to Cobalt Creed for powering this show each and every day. We want to give a big shout out to Sean and Tagliata for that. All right, well, without further ado, let's bring Deanna Hun onto the show. Deanna, how are you today?
I'm doing great, Dave.
Well, listen, here I was walking around, sweating my bones off, right, in Washington, D.C. on the National Mall, and at the Innovative Housing Showcase. And then I came across the Oak Ridge National Laboratory tents I say that plurally because it took up half the corner down there. And then I started seeing all the robotics and that were doing insulation, all the exterior cladding options that were made of different materials, and then all the scientists and the people that were behind these ideas were all standing there talking about it. And they said, you know what? Who you need to talk to is Deanna Hun. And so that's why we're talking today. But before we get into all the awards that you won and how smart you are and everything you do, we first want to know a little bit about you. So, Deanna, we want to know everything about you from the moment you were born to this very moment in time. Do not leave out any of the good stuff from the hospital, or we're going to have your team on the show, and that could get embarrassing. But you only have about a minute and a half, 2 minutes to do it. Floor is yours.
All right, here we go. After I finished my master's degrees in architectural engineering from the University of Texas at Austin, I went to work as a structural engineer at Walter P. Moore and Associates. Although the work there was exciting and challenging, I wanted to learn more about buildings, so I went back to UT Austin and got a PhD in civil engineering with emphasis in indoor air quality. But also while there, I took all the classes that the department was offering on energy savings in buildings, and that's how I ended up at Oak Ridge National Laboratory, or ORNL. And I've been here for a little over 14 years, and now I manage the group that does research on building envelopes. So that's me.
Well, you know what? This is going to be a fun conversation because I don't believe that a lot of people really know what Oak Ridge National Laboratories does, how Oak Ridge National Laboratories is out there doing things for all of us in the built environment or building the environment. And I think this is what's really interesting to me is because since I've been spending so much more time in Washington, D.C., I'm finding out that there are a lot of government agencies that are really putting effort into making things better, making housing better, sustainable, better living conditions for everybody. And super excited to get into your presentation and talk about all this. So first of all, thank you.
No, thank you for giving me the opportunity. That's why I'm here. I want to let everybody know what we're doing to improve buildings.
Yeah, for sure. So tell me, how big is your team at ORNL?
Right now, sorry, we had a few new members, but we are close. We're, I believe, 25.
You believe 25. In the department you are heading up there, tell us a little bit about the department that you head up.
I'm going to show a little bit more information in a future slide, but we do research that spans from building science to material development, system development, and advanced building construction.
Well, let's hop into it. I got your slide deck on the screen here. I think this is going to be a great conversation. In this conversation, you guys do so much. We're going to give the highlights, and then we're going to tell all of you out there how you can get involved and be part of what Deanna is doing because it is that important. And guess what? They got all the best toys to work with all this stuff, and they got the resources to do it. So we should be taking advantage of the opportunities of what you're doing. So the floor is yours. Go ahead.
Yeah, thank you, Dave, again. So I'm going to start by just giving, again, a quick overview of Oak Ridge and what my group does. And after that, I'm going to go into specific examples. So first of all, the U.S. Department of Energy, or DOE, has 17 national labs, and we are one of them, Oak Ridge National Laboratory, and we are located in Oak Ridge, Tennessee. Our mission is to develop scientific discoveries and technical breakthroughs needed to realize solutions in clean energy and national security and provide economic benefit to the nation. Okay, so we are well known because we have the nation's most diverse energy portfolio and also the nation's largest materials research portfolio. And also we have the world's fastest supercomputer. In addition to that, we do a lot of applied research. And to that end, we have what we call 8 of the user facilities under DOE. And they are listed here. And these facilities, what they have is large-scale experimental setups that are too costly for academia. So what I'm highlighting here is the Building Technologies Research and Integration Center, and that's where I work. Under BTRIC, these are the 5 different programs. We do research on building envelopes, energy efficient equipment. That means HVAC and appliances. We also do work on energy storage, buildings to grid, and system integration. And again, I lead the building envelopes work or research. And the reason why the building envelope is important from the operational standpoint or the amount of energy that your building consumes, the envelope is responsible for about 11% of the energy of the primary energy that is used in the US. With regard to the embodied carbon or the carbon in the materials that we use in building construction are responsible for about 10% of the global CO2 emissions. And with regard to resilience, the envelope at the end of the day is what is protecting us from the extreme weather conditions that we are experiencing. Consequently, we need to develop affordable and sustainable solutions that allow us to tackle the problems that I just listed. We do work on both residential and commercial buildings, new construction, and retrofits. We are well known because of our research on building science. We have been doing this work for over 35 years that focuses on decreasing energy use and improving moisture durability and maintaining occupant comfort. We have been expanding our capabilities, and now we include material and system development, and these allow us to then to tackle resilience and decreasing the embodied carbon of the materials that we use. Lastly, we have added advanced building construction, meaning that we want to increase productivity so that then we can improve affordability without compromising quality or safety. So you were asking me, Dave, about my team members. These are my, the people who do all the work under me.
All right.
As you can see, our background is quite diverse. Anything from hydrothermal simulations to AI to robotics. So we primarily are engineers, and we also have a few material scientists in the group. However, given that at Oak Ridge we have over 6,500 people, depending on the need of the project, we have access to all the researchers here. So this is here in this slide. I'm just showing an example of some of our current collaborators, and then they can strengthen, for example, our capabilities in robotics or material science as needed. And what I'm showing here are some of the partners that we have had and currently have. They vary from academia to industry, and we work very closely with industry because at the end of the day, we want our technologies to make it outside the lab. So we need that partnership to help us deploy and commercialize. So, Dave, that is a very quick introduction on Oak Ridge and building envelopes. And before I jump into technologies, do you have any questions?
Yeah, I do. So let me ask you, I see all the partners that you currently have or have had in the past. When you say partners, do they come to you with ideas of research they're trying to do to make their products better? Or are they sharing their research with you so you can develop new products in coalition with them or in partnership with them?
Both approaches that you just described, yes, they we follow both of them.
Yep.
Many times also, the Department of Energy has a call for proposals, and most of the times we have to partner with an industry in order to be able to submit a proposal. So it can be an idea that ORNL is developing, or it's a joint idea with the industry partner.
What if I'm this really smart tech guy named Dave Cooper live, and I have I think what I think is the coolest building envelope technology? Can I come to you and say, "Hey, is this something you could help me work on?"
Yeah, there are two ways in which we can do this. We can use, if we use DOE funds, yes, we can partner, submit a proposal, and help you with that. In fact, we have what we call the tech collaborations or technology collaborations, in which industry can fill out I think it's 4 pages or something like that. It's a proposal. And then it's like a voucher in which then you, Dave, can tell me, yes, I'm trying to develop this, and Oak Ridge has Y capability that can help me answer these questions that I need at this point in time. That's one approach. Another approach is you say, well, I'm loaded with money, so I can pay you ORNL, and this is what I want you guys to do for me. In that case, then all the data that we collect stays with you.
Got it. Got it. So I can use you as a research lab for my product since you have everything that I probably need to develop. If I have the money, I can collaborate with you and help develop what I'm working on. That's what I just heard, correct?
That is correct. In
Oh,
general, though, what I suggest is that you use us for research that you, for example, or to answer questions that you may not be able to answer in private laboratories. We have more advanced equipment, so consequently, then extract as much information as you can from us.
I love it. I love it. All right, let's get into the presentation here.
All right, so then, yeah, what I did then is I assembled some of the technologies that we are currently working on, and they are applicable to both on-site and off-site construction. All right, so let's start. This is the has to do with spray foam insulation, and you were talking about this earlier, and this is what you saw in DC. As you are quite aware, on the left-hand side, this shows how we currently install closed cell spray foam. The installer needs to wear PPE because of the isocyanate component in the formulation, which is toxic before it cures. In addition to that, then the installer is moving for hours this nozzle, and that wears them out quickly. In fact, what I've been told is that usually an installer may last 2 to 4 years because this type of work is so hard on the body. Consequently, what we're doing is develop the board that you see here on the right hand side.
Yeah.
It has an omnidirectional base, and also the arm can have all the degrees of freedom that a human has. In addition to that, we're adding machine vision to the bot so that it can collect in real time feedback, for example, on the environmental conditions so that it can tweak the formulation. And in addition to that, also information on the thickness of the foam that is being installed so that we at the end obtain the R value that we're after. So that's the bot, and this is what you saw in DC. Here is our prototype. We took it to DC, and also we took it to Las Vegas to the spray foam convention, and it was a huge success there. This is what we do with industry, Dave. We take our technologies out there and we gather feedback, because at the end of the day, we don't want one more thing that stays here collecting dust. We want it to go out.
So I can understand. Oh, sorry. I can understand how a robot is, obviously being able to take over that manual labor, which is, can be very hard on the body, especially if you're doing it year after year. The spray foam or the spray insulation that you're using it's not toxic. So this is something that have you changed the formula in that?
Here is an answer to your question. I also read minds here. We take classes on that here.
Ah.
So yeah, in parallel, we are developing our own foam. It is a bio-based foam that doesn't have isocyanate. Okay, and because it has that bio component, we are decreasing the amount of petroleum-based polymers with bio-based polymers, with that, which then allow us to decrease the embodied carbon by about 50%. In addition to that, I mentioned it doesn't have isocyanate, meaning that then PPE is no longer required. Does that answer your question?
So I can take this robotic machine, I can put it on a manufacturing floor in a wall panel shop or a manufacturing shop. I don't have to have a separate room. I don't have to have PPE. I don't have to move it to another building. You're saying that this technology, I can put the robots in, the robots can be however they move, and it could spray all in the same area that other people are working. Correct?
Okay, I told you I read minds. Huh?
Okay, all right, go ahead.
So yeah, certainly. Yes, I mean, in a prefab plant, the robot will probably not look like what you are seeing here on this slide, because this one is more like to go to the field, but the principles are very similar. And then, yes, we can tailor both the board and the foam insulation so that then we can use it in a prefab plant. And as you mentioned, you don't need additional ventilation and people don't need to be wearing spacesuits around.
I love it. What am I thinking now? I'm just teasing you. We didn't rehearse this, so it's kind of funny. But go ahead. Maybe.
you're you're thinking, well, what is she going to pull out now out
Yeah,
of
yeah.
the hat? Okay. All right. So then that is what we have on foams, spray foams. And what I showed you here is a prototype. We're still working on increasing its compression strength. That's why
Yeah.
it looks a little squishy. And we just got awarded money to work, or funds to work with DuPont on scaling the formulation of this foam. All right, so that's on
Congratulations.
foams. We also have, we're also developing tools that provide real-time feedback. Okay, so I'm sure that you have seen this. Somebody pours a slab and you get there with your prefab panels and things don't fit. Or, yes, things are a little off and the error keeps compounding. We have a solution here. Um, we are developing this tool called the flat and level analysis tool, or flat, that takes the information from a 3D scanner, matches it with vision, and then gives almost real-time feedback on the flatness and levelness of the slab that we're looking at. And so it is so quick that then, for example, if we're talking about a concrete foundation, then while the concrete is still workable, you know where the valleys and the peaks are, and you can ask the crew to fix them before they leave. Okay, so that is doable. And let's say, well, we were not able to do this. At least, as a minimum, the prefab manufacturer knows where these defects are so that they can adjust accordingly instead of showing to the job site and surprise, you
Right.
figure it out with shims. So, and then, yeah, so on the right hand side, yeah, I'm just showing where this is applicable: floor decks, spread footings, suspended slabs. Okay, so how does it work? So on the left hand side here, what I'm showing is what you get after you scan. You have a point cloud file. We develop is the algorithms that in less than 30 seconds can get rid of all the noise around the slab so that you just get what you need. All right. And then after you have that, we develop the algorithms that then provide those peaks and valleys that I just mentioned to you and give you this topographical map. And if it's concrete that we're talking about, it provides the results for ASTM E1155. Okay.
So let me ask you this: does it just work with concrete? Can I use it if I'm doing a steel podium to make sure my podium's level? Does it work with everything?
Yes, yes, and yes. Yes.
No kidding. So, as a former recovering, modular and panelized builder, most of my job site arguments were with the masonry trades because when I was doing it 20 years ago, they didn't understand that, hey, a quarter inch out of level over so many feet does not work. And so you're telling me that I could be the guy that runs out there, set up my machine, and go, well, you're off over there. We need to fix that before that hardens, and show them. And it becomes a tool for everybody, and the accuracy is there. I love that. Can that also pick up where the maybe the like the sewer lines are coming up through the slabs and things? Can it also pick up placement of things?
It could if we tailor it accordingly. Yes.
I
And I
love it.
was
This is my
also asked,
favorite
oh, this is your favorite? Okay, hold on
so far.
tight.
Yeah, this
So,
resolved a big headache in this industry. If this, I mean, this is a
oh,
big deal.
definitely. And you were asking for other applications, also walls. You were talking about
Yeah,
masonry.
right.
I mean, we are calling it flat, but also for vertical components, that we need to make sure that that thing is truly vertical.
Sure.
Otherwise, the error compounds. We can tweak the software so that it can also give us information that so that things can be fixed early.
Yeah, I love it.
All right, ready for more?
Yeah.
Okay, here we go. So, sealants and adhesives for prefabrication. I'm sure you have seen this. This is how we currently seal our prefabricated components. We get out there with a roll of tape, gaskets, caulk, spray foam. Even though at the prefab plant we have gotten so close to 1/16 of an inch or 1/8 of an inch, in accuracy, we go to
Yes.
the job site and this is we go back to the way we have been doing things forever. Can we do better than this? Because this is also highly dependent on the skills of the installer. Yeah. So
Yeah.
to answer that question, this is what we're developing. We're calling this an on-demand pressure triggered sealant. It is a two-component sealant in which the reactive agent is in a microcapsule, and then we put those capsules in a curing agent. And after pressure is applied, the capsules break, and then that's when the chemical reaction begins. Okay, so this can be installed at the prefab plant, and as of now, our current formulations show that the sealant can be exposed to ambient conditions for about 6 months. Because you may install it, and the part
Right.
may not go to the site until several months later. So it still remains active until for about 6 months of exposure, right?
Wow. So let me ask you this: Does that do away? Is that across the whole joint or just where it comes together?
Where you want it. I mean, it can be
Yeah.
across if you're trying to prevent air leakage with this, it will be
Yeah.
across the whole joint. Okay.
Excellent.
Yeah, and what I'm showing here is just a concept on how to do it with an OSB joint, but we can tailor. I mean, the architect or the prefab panel manufacturer can tailor the joint design for these sealant. One comment that we have received was from industry is like, well, I want to know if all the capsules have been broken. Okay, so what we're doing is developing a formulation now that will change colors after the capsules have been broken and the reaction has occurred. Okay, so then again, the joint has to be designed so that the sealant, part of the sealant, can be seen, right?
Hmm.
So then here is one of our formulations that you can see here on the left-hand side. My colleagues are just playing, to see how much load it could handle. But we do have more sophisticated equipment than water bottles to test the capacity of the load capacity of the sealant. And we were awarded an R&D 100 finalist last year with this technology. Okay.
Wow. Great.
All right. Ready for more?
All right, come on, bring it.
Bring it. Okay, so what I'm going to show you now is a package of technologies that we developed for envelope retrofits, but it is also applicable to new construction. Okay, so why envelope retrofits? About 50% of our buildings were assembled before there were energy codes. And retrofitting the envelope is typically the most difficult part to retrofit to improve because it's intrusive, disruptive, costly, you name it. Consequently, less than 2% of the residential envelopes are retrofitted each year. All right, so with this in mind, one of the approaches that we are working on is called is prefab overclad panels. It's just you assemble as much as you can at the prefab plant, and then you install it over the existing either existing cladding, or it could be that the existing cladding is removed and then you put the panels. Okay. And the thought here is that you will decrease the number of workers, the time at the job site, the occupant disruption, and waste. Okay, so in order to do this, what do we need? The first thing that we need is a digital twin of the existing building. As we know, there is no perfect facade, everything is sort of crooked. So we need accurate information on what we're dealing with. Okay, there are different ways to collect this data. There's cameras, sensor fusion, radar, but their resolution varies. But okay, so once you have that information, what do you do with it? People have been using machine learning to process the information. The problem is, though, that as I mentioned earlier, cameras and sensor fusion don't have enough resolution so that you can come with panels that fit accurately. With the LiDAR, the problem is that we need some data, labeled data, to train the information, and that is not readily available. Consequently, what we are doing is developing our unsupervised machine learning algorithms to generate this digital twin. And I'm not going to go into a lot of details. There's a paper here at the bottom, but here is just an example of what we have been able to accomplish. With this small duplex here, 32 million points from the point cloud, we were able to then generate the digital twin or the 300 point wireframe drawing. and did this in 12 minutes and have an 1/8 of an inch accuracy. Okay, as you probably are familiar, this is way faster. Other approaches would have taken at least 4 hours and would have had a much worse accuracy, somewhere at least a half an inch. And that, you cannot manufacture panels and make them fit with a half an inch accuracy. Okay,
As you develop this technology, if I can ask you a question,
sure.
is when you're developing technology, and for those, first of all, for those out there watching, when we talk about envelopes, we're talking about the exterior of buildings, whether they're new or it's a building you lived in for 100 years. We're trying to find a way to make them better, but with the technology that you're developing, are you always thinking about the cost associated with how somebody in the field can start leveraging this? So yeah, it's great we have this technology, but how do you think that through to where you can make it attainable for those in the field that could use it?
We are always thinking about cost and adoption.
Yeah.
And the reason, again, we don't want to end up with something that is just collecting dust here. How do we approach it? We typically have what we call a technology advisory group for each of these technologies, and we meet every quarter or every 2 months, depending the stage of the project. And we ask feedback. Okay, what do you think about this? Could this fly? And is this user friendly? Do you think people would use this? And with that information, then we continue optimizing.
Yeah.
Yeah, so we need to get feedback from industry. Otherwise, we're working blind.
There you go. And that's how you out there can maybe get involved in health. They're always looking for feedback. Go
Yep,
for it. Thank you.
definitely. Okay, so now we have the digital twin, and the next thing is panels. So there are various ways to make these overclad panels. We decided to go with the composite panels because we were aiming for something lighter. And what this is just a foam board that has fiber reinforced facers that can be either painted or we can infuse a color in the resin. The beauty of this system is that we can tailor its structural capacity. We can increase or decrease the amount of reinforcement. Okay, instead of making, if let's say you're somewhere where the wind loads are higher, we don't have to necessarily increase the thickness of the panel to make it to meet what is required per code. We can just add more fiber glass reinforcement. All right. So here it gives you an idea on what these panels can do. Let's say we're aiming for R30. The weight will be around 3.5 pounds per square foot, and the thickness will be about 5 inches. The facers are relatively thin. What we're doing right now is executing the various tests in a third-party laboratory so that then we can deploy these panels. Okay? So we have the panels and we have the digital twin. The next item on our list is, okay, so how do we install this stuff? Okay, so then what we're developing is called the real-time evaluator. So this is a tool that what will do, it will provide real-time feedback to the installers of these panels so that they can place them in the correct location based on the digital twin. So that is what the animation is showing you here. So yeah, and the information can be in a cell phone, a tablet, and this will replace what we currently do, which is two guys using walkie-talkies and telling you, well, move it a little bit to the right, please. Oh, that's close enough. This will do for now. Okay, now we
That's
have
right.
aim for something here. Go ahead, Dave. You have a
Oh,
question?
I said that. No, no, no. I was agreeing. I said, that's right. That's exactly how it's done.
All right. Yeah. As I mentioned to do, I did construction for a bit. So yeah. So what are we aiming for? First, this RT or the real-time evaluator has several systems. The first one is once we have the digital twin, we need to be able to align it quickly with the physical twin. So that each time we take our tracker to the field, we're not just wasting time trying to make things fit. We have developed the algorithms that do that for us. Second is a matter of the connections, okay? So how do we install them according to the digital twin? We have two approaches. One is in which the laser tracker, the robotic tracker will point, or use a laser to tell you where to put the connection, okay? And then you go and put it in place. The other approach is that once all the connections have been installed, then we can locate, get information on where they are in space, and then compare it to the digital twin, and then give feedback. So what I'm showing here is the first approach. As you can see in the top image or video, this is my colleague here. This is just a proof of concept in the lab. How much effort it would be, doing with the regular hand tools. In the bottom video, you see the laser pointing where the connection should be, and that's where Nolan is putting the connection. So, and we have yes, questions on this? All cool?
Yeah, no, I mean it's a significant time savings, right? I mean it's kind of like doing your homework and being prepared when you show up, and you just turn on your laser lights and off you go.
Exactly. You got it.
I like
Yes.
it.
And then, all right, so then now we have the connections. Next thing is, okay, figuring out where the panels are in space. So we have a mechanism or a system called the autonomous tracking system that will tell us where the panels are. And then the positioning system will is just a device where that people then can see the feedback in real time. All right. So you were asking about the costs and deployment. In this case, in particular, to keep costs low, we're using hardware that is available in the market. You have seen the scanners and the
Sure.
robotic trackers. They're out there. You have seen the optical targets that are used by surveyors. We're doing, yeah, and that's what we're using. And what we're developing here to some extent are the connection to the panels. What I'm showing on the right hand side, these are just early prototypes. So what we're doing here is developing the software to make what I just described happen. Okay. And here is our proof of concept. What you see on the left-hand side is our prototype in the lab. In the middle, the green square is the digital twin. The red square is where the panel is in real time. And the right-hand side shows the real-time feedback. And that is what my colleague there is looking at to determine, okay, is the panel in the correct place? Okay.
Wow. Yeah.
All right. So that takes giving feedback in real time. And then, okay, so we need now to put the pan, get some feedback on the installation now. I have shown you how we can generate the digital twin and then
Mhm.
get information on where things should be and where things are, and we keep the human in the loop. But this is all the necessary information for a robot to take over. We have all the information that it needs to place the panels in the correct location. So we are developing this system called the Fast, Accurate, Minimally Intrusive, or FAMI installation system. It's a cable-driven system that we're designing so that it has a slim footprint so that we can install it, let's say, on a sidewalk, and it could then avoid having cranes and scaffolding in a multi-story building. All right, and here is just a sketch of how the system could look in the future. Okay, so I showed you quite a few different
Ah,
tools. Yeah, what is your comment here, Dave?
yeah. So, hey, listen, you have. I mean, all of this is great, and it's funny you show me this system. I just had a phone call with a 3D printing company that's using clay and hay, and it's approved, and they're using a cable system similar to this to move it around because it's so easy to set up. You don't need all the big gantries, and this is a very similar concept to that, and it can be extremely accurate. I think the big takeaway for people out there that are watching this, Deanna, is you know all of this is adding up to time savings. For the stakeholder that has to do these projects, as this becomes the more of the norm in our industry, using offsite technology, using AI, using these types of systems, it all translates over time to the person that's actually paying the bill to make this stuff happening. And I love the fact that a government agency is really putting in the effort and the work to do this, because we gotta build better. We're not doing a good job. You can see that with the homeless people all around the country, if not the world.
Correct. Time savings, that's a big thing. And in addition to that, Dave, is also safety.
That's
Now
right.
we're keeping people away from some of the heavy equipment that they shouldn't be right next to or doing some tasks that are not ergonomically suitable. So, yes, both of those items. Yes. And
All
I
right.
just have a few more slides here
Sure.
before I take more questions from you. I show you quite a few technologies, and then we are also develop a platform to integrate them all. This is a digital platform that will take the information from AutoCubes, from the RTE and FAMI, and optimize so that they can all play together. Okay? And let's see what's next. Here we go. We are, you were asking, okay, so how do we take things up? We have a project with KCDC, or the Knoxville Community Development Corporation, where
Mhm.
we are going to be demonstrating these overclad panels and the RTE, and we are going to start installation early next year. In addition to that, what's next? We just started this initiative that we are calling the Born Qualified Building Construction Initiative, or Be Quick. All right. And what we are aiming to do here is to ensure building code compliance with minimal effort by automatically collecting and analyzing data and providing real-time feedback during the design, the manufacturing, and assembly of building materials or components, so they are automatically qualified. All right. So we can apply this to to material production, also to off-site component assembly, and also to on-site building assembly. And what you saw, flat and RTE, are
Yeah.
examples of these technologies. All right. And last slide here on what's next. Here, we want to show you more of what we're up to. I just went very quickly on over some of our technologies, but we could go in more detail with each of them. In addition to that, we have many other technologies that I didn't cover. And as you mentioned, and as I reiterated, we want feedback from industry. And you asked how we could collaborate. Here are a few examples. I mentioned earlier the tech collaborations, all right? And there's also, I forgot this other opportunity called Innovation Crossroads. These are two ways in which you can directly interact with us. The middle ones, yes, same thing. This you will have to file some proposals to with the Department of Energy, and in these two cases, you can select a national lab to work with you. Lastly, those two opportunities at the bottom, these are primarily for students who want to come and do an internship here. And that's it. Here's my email address. If anybody has questions or feedback, feel free to contact me.
I see. I absolutely love this, and I'm going to actually put your website up here as well, so people can just watch that while we talk. So here's the thing that I think's a big question for me. You need feedback from the field. How can I become? Can I become, if I'm a developer or a builder out there? How can I say, hey, I got a project. You want to test some of this equipment on my project, and I have a client that's willing to do it. Is there a possibility of that?
Oh, definitely. In fact, FLAT and the real-time evaluator, we are ready to take it to the job site. We have an industry partner that offered us a to do a trial at their
Yeah.
site. But if there are other ones, we're taking, yeah, this we're ready to go out to the field. So
What
yes, if you have, and this is what will help us better satisfy the needs from industry.
and they can reach out to you directly based on the email that you have on this form right
That
here,
is
right?
correct. If there's
Whoop.
something that they saw here and they say, yeah, I want to try that, certainly shoot me an email.
What Deanna? What are some of the biggest challenges that you find in our industry, or at least for you? Like when you sit there and you look, is it not enough people know what you're doing, and not enough people really understand what Oak Ridge is doing? What do you find is the biggest hurdle to overcome for people to really be involved and understand what you're doing out there?
I think, as you mentioned, not many people do know about us, but at the same time, it's also embracing or at least trying new things. Okay, you're in construction, as you know, there are many who are set in their ways. There are a few who are willing to try new things. And bear in mind, from what you saw, not everything that I showed means that, oh, we're changing all the procedures. Some
Yeah.
things, I mean, are easily adoptable now. And this is the kind of, we are aware that there are steps. The world is not going to change tomorrow.
Yeah.
But yeah, I want people that are willing then to talk to us, and let's, have a short-term plan, mid-term plan, and long-term plan to make our buildings better.
How much do you love your job?
Oh, I really like it. Can't you
I can
tell?
tell. Hey, listen, I think, and this is what I love about what I do for a living now. I always have conversations with people that are trying to build it better, trying to do better, really make a difference in the world and in the lives of people, not only on the job site, but in your case, also the habitants of whoever's occupying the buildings, whether it's single family or a commercial building. And I think there's a lot to say about loving what you do. So that's why I asked that question.
Yeah, definitely. I love construction. I love buildings, and I have all these capabilities here at Oak Ridge that, I mean, the sky is the limit.
It is the limit. And I'm going to just throw your bio up here one last time before we wrap up. I really want people to understand you're not just talking the talk. Look at all these awards and trademarks and patents that you have worked on through your career on behalf of all of us out there. And, I don't think there's enough that can be said for the work that you're doing. So I really personally, on behalf of our entire audience, I want to thank you for one. Two, you're a fun person to have on the show. So you make the show exciting and fun. You're talking about great stuff. And three, you're everything that we talk about on this show when it comes to how we're going to build it better. So thank you.
Well, thank you for the opportunity. I enjoyed it.
Did I miss anything that you really want to make sure people know about what you personally do or what Oak Ridge is doing?
I don't think so, but as I mentioned earlier, I would love the opportunity to dive deeper into some of the some of the technologies that I presented. Also, have the opportunity to talk about the low carbon materials that we're working on, our approaches, what's coming next for you guys. Yes, I would love that.
Well, when we wrap up this show, we're going to get some more dates scheduled, and maybe we'll break down each and every one of those projects or things that you're working on and showcase them here, and we can get into the nuts and bolts of it. You got your PhD, so I know you want to get into the dirt on this stuff. So let's do that. So Deanna, thank you.
You're welcome.
And everybody else out there, thank you. Guess what? It's Wednesday. And what happens on Wednesday? That means you still got 2.5 days to keep building it better before you chill out with your family on the weekend. So I want to thank you for joining us today. Deanna, thank you for joining us today. And for the rest of you out there, let's keep building it better. We need a more sustainable, healthier place, not only for us, but for the future and the children of this world. So let's keep building it better. And people like Deanna and her team are doing that for us. Here's another word from some of our other supporting members. Please make sure you watch this and thank them, because we cannot bring you any of these conversations without the support of them. Thanks, Deanna. Stay right there. I'll come back to you after this. What an amazing show. Thank you to all of our sponsors for helping us to continue to bring all of these innovative conversations to all of you out there. Please visit them, see what they have to offer you. And as always, subscribe to the YouTube channel and ring that bell. It would mean the world to us. I'm Dave Cooper. Thanks for watching.